All right, hello, welcome back. We are moving on. I'm kind of hopping around in the math just so we don't uh, drill you to death with algebra. I'm going to kind of hop between algebra stuff and not algebra stuff, kind of back and forth. We'll hit it all eventually. What are we looking at today? These are relatively simple algebraic operations. What am I talking about today? We'll talk about them as we go. We're talking about things like combining like terms, distributive property, solving for a variable, foiling, solving for stuff, adding and subtracting polynomials. That's what we're going to be looking at today, doing some straightforward algebraic operations. We have variables now, it's like last time. Which of the following is a simplified form of the expression 4 times quantity 2 plus 5x plus 9 minus 2x? Okay, it's looking for a simplified form. What is it asking for? It's asking us to simplify. What does simplification often mean? Simplification often means combine like terms, and it might involve some distribution. You're gonna, I'll have a key later where you correct yes or no. What did you have to know to get the correct answer? That's something you're gonna have to look at later. But what you have to know, you had to know how to combine like terms and distribute. That's really what you had to know to get the answer correct. What I'm gonna be asking you to do, I'm gonna give you the key, right? It's not a lot of effort for you to say, "Oh, well, he gave me the answer, so I can circle the answer." That's not impressive. So to hold you accountable on this stuff, you're gonna have to say, "Okay, do I know what the name of this concept is? Can I recognize the concept?" And if you don't recognize the concept, you talk to me about it. And this is how I'm gonna hold you accountable. I'm not gonna give you this. You have to kind of look it up or ask me. Or listen to the video, but I'm not gonna just print all of this for you to copy, like some of you might have done in science. No, never. For the equation 5y plus n equals m, which of the following expressions gives y in terms of m and n? When it says gives y, what's it asking for? It's asking for you to solve for y. If you ever see that gives y phrasing, gives something, that's asking you to solve for it. All right, so you're asking to solve for y. All right, so 5y plus n equals m. Trying to solve for y. All right, so 5y, if you subtract an n from each side, 5y becomes m minus n. And then dividing each side by 5 to solve for y. Y equals m minus n over 5. Can solve that pretty quick. That is g. The thing I might remind you, what do you have to do in algebra? The big rule of algebra. Big rule of algebra. Do the same thing to both sides. EQ is equation. Big rule of algebra. Do the same thing to both sides of an equation. If you do it to one side and you do it to the other side, they're still equal. Cool. So I'm gonna work through like 6 or 7 more. These you got 45 total to do. I'm gonna do like 10 of them for you. It's 35 questions. 35 questions take less than a minute piece. You got like half an hour of work to do once I'm done here. All right. Is equivalent to what's that? It's asking us to multiply it out. What's the question asking for? An equivalent form. What are you gonna have to know? You're gonna have to know how to FOIL. First, outside, inside, last. If I multiply the first two terms together, I've got 10 CD. If I multiply the outside terms together, I've got minus 25. C times C is C squared. Negative 3D times 2D is negative 6D squared. All right, so what have I got here? Negative 25C squared, negative 6D squared. Okay, so I got to finish it. Negative 3D times negative 5C is plus 15CD. Okay. We had 10 plus let's notice some things. We got negative 25c, we got negative 6d. It's got to be one of these two. 10 CD plus 15 CD is 25 CD. Answer is D. There's a property there that we need to know. That property is that a to the m times a to the n is a to the m plus n. What did that come from? When we multiplied the d's together. So that is a property of exponents. One of those things that you need to be sure that you've written down. So we can keep moving though. We've got exponents. We know how to do exponents, hopefully. Given the equations b equals x plus 2, y equals a minus 4, which of the following expressions is equivalent to b plus a written in terms of x and y? You never really have to worry about the written in terms of, because you're what's b plus a? Well, b plus a, I can rewrite it as substitution. What do I have to know? I have to know how to do substitution. B plus a, that is x plus 2 plus, oh, what's a? Oh, I got to solve for a. Y is a minus 4. Solving for a equals y plus 4. How do I get that? I add 4 to both sides. When I add those together, what do I get? X plus y plus 2 plus 4 is 6, and we've got an answer, hopefully pretty quickly, of G. What's it asking for? It's asking for an equivalent form. We're not asked to solve, we're just asked to rewrite it. What is it? Yeah, what does equivalent form mean? Rewrite in a different way. Number 5. Oh man. Oh man, you've been asked this question before and so many of you missed it. Why? You're asked to subtract these two things, but if you're asked to subtract, you have to subtract every single one of those things. And what can we combine? We put the a's together. 4a minus 6a is negative 2a. Okay, right away I say it's not going to be e. All right, 7b minus 6b. We can only combine like terms here, same exponent. 7b minus 6b is 1b, okay. Cross out c and d. Now we've got it down to a and b. See what I'm doing here? I'm working through the problem. I'm eliminating answer options as I go. 6c, I'm going to put 3 lines under a c. 6c minus 3c, 1, 2, 3. Oh, minus negative. 6c minus negative 3c, that's 9c. Minus a negative is plus. Answer here is A. What do we have to know? Again, it was asking for another equivalent form. What do we have to know? We have to know like terms, and we have to know that, you know, C minus negative C is C plus C is what we have to know. Subtracting a negative is adding. So about halfway through the ones I'm going to work for you. Just got a few left here. I think I'm going to work 7, 9, 11, 12, and 18. Yes, 5 left. Another one, about as straightforward as you can get. You see this one, you should be pretty happy. 3x to the 5th times 7x to the 9th. Okay, 3 times x to the 5th times 7 times x to the 9th. Okay, you better know that 3 times 7 is 21. Okay, hot dang. And we can get it down to 2. I can multiply those together. X to the 5th times x to the 9th. You need to know, once again, that if you multiply things, with the same base, add the exponents, m plus n. So that's times x to the 5 plus 9. X to the 5 plus 9 is 21. X to the 14th, that's an answer of J. So again, same down low, add the exponents. We can see that same principle, but with more variables down here. The product of this thing is equivalent to, okay, what do we got to do? 2 times 4 right away is 8. Okay, so I know it's not F or G. x to the 3 times x to the 5 is x to the 3 plus 5. 3 plus 5 is 8. Okay, so it's not k. And then y times y to the third. Ooh, that's y to the 1 times y to the third. That's y to the 1 plus 3. 1 plus 3 is 4. H is your trap. What did you have to know there? The exponent rules again. What is the question asking for? It's asking for another equivalent form. What do you have to know to get this correct? Again, a to the m times a to the n equals a to the m plus n. If we have the same base, we add those exponents. Not bad here. 2 left, I think, 2 left, 3 left. Number 11 is a goofy one. If oh my God, what is the value of x minus y? All right, what is the value? What is it asking for? It's asking for to rewrite and solve for x over y, not x minus y, but x over y. So I need to solve for x over y. So, all right, 5 minus 5. All right, what is it? 5 minus 5 minus y equals 5 minus 5 plus x. Okay, 5 minus 5. Okay, so negative y equals x. Well, how do I get x over y? Oh, I divide each side by y. Divide by y. Divide by y. X over y. What's y over y? X over y here equals negative 1. So solving for x over y, let us see, what is it equivalent to? 2 left. Number 12 is one that just, oh my God, what is this? Cross with a circle. You just plug the stuff in. All right, we got this cross. All right, a cross b is a plus b over 7. All right, so what is this business? 98 cross 77. Okay, that's 98 plus 77 over 7. What is that? I don't know. 98 plus 77 over 7. 25. Great. So we've got 25. And what's this other thing? 21 plus 49 over 7. I can do that one in my head. That's 70 over 7 is 10. All right, so now we got to do 25 cross 10. Great. This is weird. 25 plus 10 divided by 7. Oh, great. 5. Fantastic. Do I know what's going on? Not really. I might remind you to put parentheses around your numerators if you want to. That's going to make your life easier. You're not going to miss as many fraction problems. Okay. One left. Has a different property for you. Division of things with exponents. I will remind you here, just as a to the m times a to the n is a to the m plus n, a to the m divided by a to the n is a to the m minus n. You're going to need that here. What do I mean? We're going to need that here. What is 5 over 2? 5 over 2, 5 divided, or a to the 5th divided by a squared, that's going to be a to the 5 minus 2 on top. On the bottom, well, what are you going to have here? You're going to have b to the 3 minus 7. Oh, no. And we're going to have c to the 4 minus 1. And we're still going to have a 5 on the bottom. That's not going anywhere. A to the 5 minus 2, what is that? A to the 5 minus 2, that's a to the 3rd. All right, is there anything that's not a to the 3rd? And cross out d and e. All right, we're going to have b. 3 minus 7 is negative 4. Oh, going to need another property in a moment. We'll come back to that. And c to the 4 minus 1, that's c to the 3rd. So right away we can cross out, oh, I don't even have to do the work. C to the 3rd, it's not c. C to the 3rd. Okay, it's not that, because, well, what is even going on there? That looks goofy. Where's c to the 3rd? We've only got one c to the 3rd. It's got to be a. What's the other property we could have used? We could have used the property that a to the negative m equals 1 over a to the m. What does that mean for us here? That means we could have taken this b to the negative fourth and rewritten it on the bottom, a to the third, c to the third over 5, b to the fourth, and that could have been our proven final answer there. So that's what I've got for you. It's exponents. If you're multiplying them, you add them. If you're dividing them, you subtract them. What are like terms? They have the same exponent and variable. You got a lot of problems asking you to do that, asking you to FOIL, asking you to plug stuff into newly defined functions. But I've given you a good start on it. Please, as you're going through, write some things out there to the side. I'm not asking for a ton. And if you don't know what to ask, call me over. You're getting 2 days to turn everything in, so I will see you before you have to turn something in. Ask me on the day I see you. Cool. Next time, I'll have something new for you. We'll see you then.